You're looking at a 27 billion parameter AI model running locally on Windows, and its core file is only 7.17 gigabytes. But that headline leaves out the most important question: does complete running model also fit inside 7 gigabytes? I am testing real file size, live memory, reasoning, Windows code, and offline operation. Stay for the final scorecard because 7 gigabytes claim is technically true, but only if we are very precise what 7 gigabytes actually describes. Before the test, here is the machine. I am using Windows 11, a AMD Ryzen 7 with 12 GB of VRAM and 32 GB of system memory. I am testing the official Ternary Bonsai demo, not a different model with a similar name. The first gate is storage. How large is the actual Q2_0 language file? The second is memory. What happens when it loads with a 4K context? The third is usefulness. Can it reason, write working PowerShell, and respond with the internet disconnected? Every verdict will come from this recording, not from a vendor benchmark. Here is the basic idea. In a conversational FP16 model, every weight uses 16 bits. Ternary Bonsai restricts the language weights to 3 states: -1, 0, or +1, with a shared scale for each group of weights. Think of replacing thousands of precise dimer controls with simple 3-position switches, while one master control preserves the overall level. That dramatically reduces storage. A normal 27 billion parameter FP16 model would need roughly 54 gigabytes just for its weights. This deployed GGUF. For Windows, I create a clean AI folder, clone the official Bonsai demo, select the ternary family and the 27B model, and allow local PowerShell scripts for this session only. Then I run the setup script. It checks the environment, downloads the required files, and chooses an available backend. On this machine, it selected backend. I have shortened the download in this edit, but the elapsed time label is the real time from my recording. Also, I am not showing any access token or private path. The installation completed successfully. So now we can stop talking about the claim and measure the actual file. This command measures the core Ternary Bonsai 27B Q2_0 GGUF file directly from disk. The result is 7.17 decimal gigabytes or 6.68 gigabytes. Both numbers are correct. GB and GIB use different divisor. This is why one screenshot may say 7.17 while Windows reports a value closer to 6.68. So the first claim passes. The core 27B language weights really do fit in roughly 7 gigabytes. But this is not the whole download. The model folder may also contain the vision projector and speculative decoding files. More importantly, a file sitting on a disk is not the same as live inference session. Gate 1 passes, Gate 2 is the real I am starting from an ideal reading of ideal memory with Windows and the recorder already running. Now I am loading the text only model with a 4096 token, context and a capped reasoning budget. That keeps the vision component out of this first measurement. The load takes load time, peak memory reaches the peak memory, and generation runs at approximately generation speed, tokens per second on this machine. The important point is that the complete session needs more memory than 7.17 gigabyte file. The published 4K text estimate is around 7.8 GB before we allow comfortable overhead. The weights fit, runtime memory is tight. For the remaining test, I am starting the local Llama server. The browser is connected to 127.0.0.1, which means this interface is being served by my own Windows machine. 7 GB test. An 8 GB GPU has 0.6 GB in use, leaving 7.4. The session needs 7.8, a 0.4 GB shortfall. Reasoning passes, but full GPU offload fails. Memory remains tight. Arithmetic is useful, but I also want to know whether this compressed model can produce something practical for Windows. I am asking it to write a PowerShell function called getFileSizeReport. The function must accept file path and return both decimal gigabytes and binary gigabytes, rounded to 2 decimals. I also told it to output only runnable code. I am copying the first answer into a clean PowerShell window and running it against the actual GGUF file. The generated function executes successfully and returns 7.17 GB and 6.68 GB, the same values as my verified command. That is a practical pass. It followed the format, produced working Windows native code, and reproduced the measurement. Final check is whether it still works offline. The model is already loaded and the browser is connected to 127.0.1. I am turning off Wi-Fi now. With no internet, I'll request a beginner-friendly analogy under 80 words, editing with a specific phrase. The response still arrives locally and follows the instructions. This confirms the model session continued running on my machine. Here is the scorecard from this Windows test. Here is the honest scorecard. The 27B model fits in about 7 GB, but the full runtime does not. Memory usage increases with context, vision, and other software. Reasoning, PowerShell, and offline inference all pass. So yes, to 7 GB weights, but no to a 7 GB complete setup. Would I use it for Windows smoother GPU experience? I would target 12 GB VRAM or more. With 8 GB, keep the context small, close GPU heavy applications, and expect that partial offload may be necessary. CPU and system inferences are possible, but speed is the part of the decision. If you want more claim versus reality tests like this, subscribe to AICK Studio and comment with your GPU and RAM.